So we stated that in time t, the moving molecule will make collisions with all the molecules whose centers will be lying within the imaginary cylindrical volume of the length c bar t and cross-sectional area pi sigma square. And according to this diagram, we saw that in time t, this moving molecule is sweeping out this cylindrical volume whose length is c bar t with cross-sectional area pi sigma square, and there are 9 molecules lying within this cylindrical volume. So the number of collisions made by these moving molecules in time t is 9. But this is just a specified case for this, according to this diagram. But in general, what will be the number of collisions made by a moving molecule in time t? So that number of collisions made by a moving molecule in time t will be equal to the number of molecules contained within a cylindrical volume of length c bar t and cross-sectional area pi sigma square. Now, to calculate the number, first we find the volume of this cylindrical, this imaginary cylinder. Okay. So, the volume of the imaginary cylinder swept out by the moving molecule in time t will be equal to length of the cylinder multiplied by the cross-sectional area of the cylinder. So, it is length of the cylinder into cross-sectional area of the cylinder. So, we know length of the cylinder is c bar t into cross-sectional area, which is pi sigma square. So the volume of the cylinder is pi sigma square c bar t. Okay. So now let the number of molecules per unit volume be n. So if the number of that is so it is the number density of the molecules. So if the number of molecules per unit volume or number density of the molecules is n, then how many molecules will be contained within this cylindrical volume? So the number of molecules within the cylindrical volume will be equal to volume of the cylinder multiplied by the number of molecules per unit volume or number density. Okay. So the number of molecules within the cylindrical volume will be product of the volume of the cylinder and the number density. So the volume of the cylinder we know, we just calculated it. It is pi sigma square c bar t into the number density, which is taken to be n. So it is pi n sigma square c bar t. Okay. So these many molecules are contained within the cylindrical volume, within this cylinder of length c bar t and cross-sectional area pi sigma square, which is swept by our moving molecule. So the moving molecule will make collisions with these many stationary molecules which are contained within this cylinder in time t. So these are the number of molecules. This is the number of molecules which is contained within this cylindrical volume, and this will be equal to the number of collisions made by the moving molecule in time t. Therefore, we can say in time t, the moving molecule will make collisions with this pi n sigma square ct number of molecules. Or in other words, we can say that the number of collisions in time t will be equal to this number, which is pi n sigma square c bar t, as these many molecules are contained within this imaginary cylinder. Therefore, what will be the mean free path? Mean free path will be the distance covered in time t by the moving molecule divided by the number of collisions in time t. So what is the distance covered in time t by the moving molecule? It is this much distance, c bar t. So because the moving molecule is moving with an average speed of c bar, so distance covered in time t is c bar t. And what is the number of collisions in time t? It is equal to this number. So it is pi n sigma square c bar t. Therefore, mean free path will be, so c bar t and c bar t will get cancelled out, and therefore mean free path lambda is equal to pi n sigma square. Okay, but this expression is very simple because at the beginning we made some very simple assumptions, right? That there is only one molecule moving and the others are at rest. Okay, so which is very idealized. Okay, and it is just an approximation. So hence it needs to be modified, and the modification was done by both Clausius and Maxwell. So Clausius considered that not only one molecule is moving and others are rest, but all the molecules are moving, but with the same constant speed. Okay, so all the molecules are moving with the same speed, and that speed will remain constant. It will not change with time, and they are moving in all the molecules are moving in all possible direction. Okay, so with this consideration he got this expression for mean free path lambda, which is given by lambda equals to 3 by 4 pi n sigma square. Okay, next Maxwell did even improve this result even further by considering the distribution of molecular speed. So we already know that the distribution of molecular speed, that the molecules can have any velocity varying between 0 to infinity. So in case of Clausius, he assumed that all the molecules are moving fine, but they are moving with its same constant speed. But Maxwell said that all the molecules are moving, but they are not moving with same speed. They are moving with different number of molecules are moving with different speed. That is, he considered the distribution of molecular speed, and he obtained this result where lambda is given by 1 by root over 2 pi n sigma square.